All right, so we are looking at the second half of chapter 12, and we're just looking at the probability piece of it. So we did the statistics in our first part, and now we're looking at probability for 3 sections. So we are going to first talk about sample space. So sample space is every single option that could possibly happen. Okay, so if we're rolling 2 dice, okay, so we could get 4 and 4, we get 4 and 1, you get 3 and 2, all of those different options. Okay, so listing every single option is called the sample space. Okay, so getting a 1 and then a 4 is different than a 4 and then a 1. Oops. Okay, so it would be good to do some sort of organized fashion. Okay, so we could say getting a 1 and a 1, 1 and a 2, 1 and a 3, 1 and 4, 1 and 5, 1 and 6. What would the next row be? 2, 1, 2, 2, 2, 3. We're not going to list them all, but that's how you should build a sample space so that you make sure that you are not forgetting any of them. So do it in a pattern. What would the last row be? 6, 1, 6, 2, 6, 3, 6, 4, all the way up to 6, 6. Okay, after you write your sample space, then they're going to ask you questions on it. Okay, so we're going to try this with flipping coins. All right, so let's say you have 3 coins. List the sample space of those tosses. So you're going to flip all 3 of them. So let's do this in an organized way. What are the options if we flip 3 coins? So the 3 flips, what would be one option? Let's do it organized, so not just a random one. We could get heads, heads, heads. What's another one? How about we start with just getting one tail on the flip, okay? And then we'll go through each option. So it could be tails, heads, heads, tail, head, tail, head, head, tail. So just moving that tail to the 3 possible positions. The first flip, second flip, and the third flip. Okay, what should we do next? Getting 2 heads instead of 1? Or 2 tails, I mean? Okay, so we could have tail, tail, head. Tail, head, tail, head, tail, tail. And then tail, tail, tail. Okay, that's all of them. So if they ask you for the sample space, you're done at this point. You've listed all the possibilities that could happen. Okay, then they may ask you some questions based on that sample space. Okay, list the following events. What is the options where the toss is exactly 2 tails? It's right here, right? Those have 2 tails? Okay, it doesn't say what is the probability, it says list them. Okay, so we have tail, tail, head, tail, head, tail, head, tail, tail. So don't write the probability when they ask you to list the events. Where are the situations where there's at most 1 tail? Which ones have just at the very most 1 tail? That's it. It's also heads, heads, heads. Okay, at the very most there's 1 tail, so it's possible that there aren't any. Questions there? Biggest mistake on these problems is kids forget that I'm asking you to list them and they write probabilities of those things happening. Okay, because the rest of the time we're really going to be focusing on probability. We good? All right, so jumping into that probability. Probability of some event happening is the number of desired outcomes out of the total number of outcomes. Okay, so let's look at this situation right here. We have 40 marbles in a bag. We have all of these colors listed here. I want to know the probability of picking a red or a blue marble out of the bag. Okay, so based on this equation up here, what's the bottom number going to be? Total number of marbles is 40. Okay, we want to know the probability of picking red or blue. What's the top number going to be? There's a total of 15 red and blue marbles. I do not need you to reduce your fractions. Just leave them as they are. That shows me that you know that you're getting this 15 from here and the 40 is the grand total. Don't worry about simplifying or turning into decimals at this point. All right, probability of anything but green. How are we going to do that? Okay, so just take 40 minus the green marbles. What is that? 27 out of the grand total of 40. Done. Questions there? All right. Okay, so yes, I am expecting that you know what cards are in a deck of cards. Okay, many standardized tests are going to assume that you know what's in them. So if you don't know, you need to know. So this right here shows you all the different cards in a deck. There are 4 suits, 2 are black, 2 are red. There are 3 face cards in each suit. Okay, there's also an ace in each suit. So you need to know this list of cards right here. Most people do, but some people just aren't used to needing to know that. So we need to talk about, let's say we shuffled this deck. What is the probability that we would pick an ace? The 4 is the desired outcome. There's 4 aces out of the total of 52. Okay, what's the probability we pick a red one? There's 26 red ones, 52 total. I'm not going to have the jokers in any of the problems that we do. Okay? So it's just these 52 cards. Okay? Questions? All right. So now we're going to take it a little step further here. This bag has 4 red, 9 blue, and 11 yellow. 2 marbles are chosen at the same time. Is this independent or dependent? So listed right here on this picture, with replacement, which means you put the marble back, that is independent. Without replacement, so you hold the marble in your hand and then pick another one, that is dependent. Okay, so if we pick 2 marbles at the same time, which one is that? That is dependent, okay, because you're going to end up with both marbles. It's the same thing as picking 1 marble and then picking another one and holding them both in your hand. Okay, so know that if you pick them at the same time, it's the same thing as picking one at a time and holding on to them without putting them back. So some situations are going to say, what's the probability you pick a marble, put that one back, and then pick a different marble? That's a totally different problem than saying, what's the probability you pick this marble and then pick another one with it? So we calculate those probabilities differently. Okay, so let's look. I'm going to have you guys walk me through. I'm going to write them up here. 4 red, 9 blue, 11 yellow. I can scroll down. Okay, what's the probability that both of the marbles are blue? Okay, what's the probability that the first one that you pick is blue? I'm only hearing one person participate, which makes me think that you guys aren't understanding. Probability that the first marble,
9 out of 44.
there are 24 marbles. The first marble, the probability that we pick a blue one is 9 out of 24 because there's 9 blue marbles, okay? So now we have a marble in our hand, okay? What's the probability that the next one is going to be blue?
8 out of 23.
Why is it 8 out of 23? Okay, so there's one less marble. We have a blue marble in our hands. So now the probability that we're going to pick another blue marble would only be 8. And there's only now 23 marbles in the bag, grand total marbles. Okay, what do you think we're going to do with these probabilities? We're going to multiply them. Okay, so we got 72. Someone tell me what the denominator is. Okay, so just so we know, that's the answer to that question up there. These are dependent questions. Okay, what is the probability that one is red and one is yellow? What do you think? 4 out of 24. 11 yellow out of 23. So one red and one yellow. Okay. Now this isn't the total answer, but we're going to go with it for now and we'll come back to it. Okay, same denominator. And we got 44. Okay. Now did it say that the first marble we picked had to be red? No. It just said that one of them that you pick is red and one of them that you pick is yellow. So we also have to find the probability that the opposite thing happened where we get the yellow one first and the red one second. Okay, so which would simply just be 11 out of 24, 4 times 23, which we get the same answer, right? Okay, what do you think we're going to do with these two probabilities that we just found? I'm not going to multiply them. We're going to add them together because both situations could happen. Okay, so we're going to get a grand total of 88 over 552. Okay, sometimes I'm going to tell you the order specifically and you don't have to check both cases. Okay, what's the probability that the first one is blue and the second one is red? Then you just have to check that one. But if I don't tell you in order, you have to do both situations. Okay, what's the probability that none of them are yellow? Well, let's just do one at a time. What's the probability that the first one is not yellow? How many are not yellow? 13 out of 24. What's the probability of the next one not being yellow? 12 out of 23. Okay, what's that number? Okay, again, don't worry about simplifying your fractions. Okay, I don't want you to because I want your answers to match what's in my answer key. And I just stopped once I found the probability. Questions here before the last page? All right. We have a deck of cards. One card is picked and then put back in the deck. Then a second card is picked. Okay. So what is the probability that the first card is an ace? How many aces? 4 out of 52. Okay. The second card is black. There are 26 black. What's the number here? It's 52. How come? We put the card back before we drew the next one. Okay, so what are these numbers? Is that 104? What's this one? Anyone? Thank you. All right, this one. We're going to pick a card and we're not going to replace it, then we're going to pick a second card. So what's the probability that the first card is a spade? How many spades are there? 13 out of 52. We're not going to replace it, so I already know this is 51 because we're holding that card in our hands. The second card is a 6 of clubs. How many 6 of clubs are there? 1. So we got 13 out of